All right, welcome to our next lesson today. Our goal today is to know and be able to use algorithm for dividing and identify the part of an expression. So a continuation from the last lesson where we looked at algorithms for add, subtract, multiply, and divide. Today there's going to be a lot more hands-on practice of dividing. Here's your warm-up. I want you to go ahead and try this one on your own, and when you're done, come back. We'll see how you did. Okay, here are the answers you should have received, and hopefully you wrote these down in your notebook with showing your work. You'll see for 2 and 3 we had a remainder. I wrote it as a fraction. We're going to talk about making sure we always write our remainders as a fraction as we go forward here. So hopefully you did well, and we're going to move on. Here's a scenario that we're going to think about to get ourselves started. So it says every year students take the school bus to and from school. There are about 480,000 school buses in the United States. There are 25,920,000 students total who actually take the bus. Again, these are averages or estimates. You can use division to find out how many students are actually on the bus. And yes, it's a big number, but yes, we can also make this work. So when you're given a problem like this, just remember that you have divided in the past. This is no different. You're going to have to use, as you learned from last lesson, an algorithm that you can use the same process over and over, and I'll be giving you an algorithm in a little bit. But let's get some notes written down. Let's review what the parts of a division problem are. Dividend, okay, dividend is the number to be divided. That's your dividend. A divisor is the number by which the dividend is divided. So when you look at your fractions like this, the divisor's on the outside, the dividend's on the inside. You'll also see division problems this year and from here on where they look like fractions. So if that's the case, the dividend goes on the top while the divisor will go on the bottom. Because the way to think about this is the divisor is the whole. These are the whole groups. 480,000 is your whole group. The dividend is the parts. How many people are going to fit into each one of those groups? Now, we're not going to solve this right now, but I do want you to look at it and say, how are we going to solve this? By the end of the class, I think you'll be able to solve this and feel a little more comfortable. One thing you can probably look at with this number is the rules with 0. If you crossed off, they each have 4 zeros. If you cross those off, you get a much smaller number. But let's get these notes written down, and then we'll move on when you're ready. Okay, here is a scenario to think about for our example 1. And it's going to kind of be notes as well, but let's put example 1 in our notebook anyways. All right, you're going to find a group size using division here. In the United States government, there are 435 members of the House of Representatives. The members are usually split into at least one committee, and they try to split them all equally into different committees, 15 different committees. There's committees about the military, committees about budgets, and so on and so on. Anyways, if we were to figure out this problem, what we need to do is we need to know the algorithm that we're going to use. Well, the algorithm is right here. And this I want you to put in your notes before we go on any further. Okay? Just going to go away. Sure hope it goes away. There we go. Step 1, whenever you're dealing with two numbers like this, you have to decide where to place the first digit in the quotient. Step 2 is then divide by the divisor into the dividend as close as possible. Step 3, bring down the next place value. And step 4, continue until you have a remainder as a fraction, it says or as a decimal too, and your answer is done. So get these steps written down, and then on the next slide, when you come back, we're going to actually do this problem. All right, so let's go through this problem. So really what we're dealing with is 435 divided by 15. So again, I wrote it as a fraction just kind of to show you, but this is really how we're going to do the work. Let's put that together. All right. So when solving this, the first step says decide where to place the first digit in the quotient. So I have this box, And what you do is you start all the way to the far right and you start covering up. Let's see if I can make this come to the front. Okay, I can't figure it out. So here's how it works. You start all the way at the end here and you just look at the first number, which is a 4. And you're asking yourself, can 15 go into 4? And the answer is no, it's not big enough. So you slide down to the next place value. Now we're just looking at 15 and 43. So can 15 and 43, stop touching all these things. Can 15 and 43 work together? And the answer is yes. Let's use a different color. 15 goes into 43 twice because 15 times 2 is 30. So now as you're looking at it, you're dealing with much smaller numbers. You're just doing them in small chunks. So now we have to divide the divisor into the dividend and get as close as we can, which we did. And now we're going to subtract. 43 from 30 leaves you with 13. Then step 3 says bring down the next place value. So we find the next place value is the 5, and we add that to the 13 that's already there. Now you're going to say how many times does 15 go into 135? And here's where you have to either know your math facts or you have to kind of guess and work your way through it. So I know my math facts. I know my multiplications of 15, so I'm going to work through them. There we go, 15, 30, 45, 60, 75, so we're 5 up now. Then it goes 90, then it goes 105, then it goes, I missed one there, I think. Oh, 120, 120, 135. So how many times will 15 go into 135? The answer is 9. And it actually goes in evenly. So 15 times 9 gives us 135. And when we subtract, we have nothing left. So that means we're done. So the answer would be to the question that there would be 29 members per committee. And every single time I deal with large numbers or smaller numbers, I'm going to use the same process to try to solve them. These 4 steps, this algorithm. So have this example down, and once you have it written, then we'll move on to the next slide. All right, now it's time for you to do a little bit of practice on your own. I have 2 problems here. I'm going to pause the video. I want you to pause the video and try to solve these 2 problems. Show your work in your notebook before moving on, and once you're done trying these out, then come back and we will see how you did. All right, so let's go through these together. So the first one we're looking at, Amanda wanted to save how much money, and she has 25 weeks to save it. So there's our groups, and there's how much we're working with. So I wrote it down here as 25. We're going to see how many times that goes into 1,450. So you start all the way here, and you say, does 25 go into 1? The answer is no. Is 25 going to 14? Nope. But it will go into 145, so that's where we're going to start. So you have to start going, how many times do you have to multiply 25 to get up to 145? 25 times 1 is 25, then 50, then 75, 25, 50, 75, 100, 125 would be 5, 6 would be 150, that's too much. So 25 times 5 is 125. When we subtract that out, we're left with 20. Now 20 is smaller than 25, so we have to keep going. So we slide over and we see that we have one more place value, and that we have to bring down, and now we have 200. So you have to figure out how many times 25 goes into 200. Well, we know that 25 goes in 5 times, it makes 125. So if we keep going, 6 would be 150, 7 would be 175, and 8 would be 200. So 25 times 8 is 200. And when we're done, we're done. So the answer is 58 weeks. That's how long she's going to need to save to figure that one out. So hopefully you got 58 weeks. Let's look over at number 2 now. So here we're looking at an aquarium having 29 large fish tanks, and they have 1,423 fish that they need to keep in the tanks. They want to have it as even as possible. What's the greatest number of fish that will be in one tank. So again, we cover everything up except the 1. Does 29 go into 1? Nope. Does 29 go into 14? Nope. But 29 will go into 142. Now 29 is a tricky number to work with. They should have just had 30 fish tanks, and that would make it a little easier. But they don't. But we can use 30 as that compatible number to get as close to 142 as possible. So if we think 30, we know that 30 will go 30. 30 goes 30, 60, 90, 120, and 150. So that gives us 5. So here we're just going to have to guess and check a little bit. Let's try 29 times 5 and see what that gets us. So 29 times 5 gives us 45. 5 times 2 is 10, plus 4 is 14. Now 145 is close, but it's still too large. We need it to be less or equal to 142. So let's go with 29 times 4 and see what we get. I'm going to put the 4 right up here so we don't lose it. 9 times 4 is 36, carry the 3. 4 times 2 is 8, plus 3 is 11. 116 will work. So let's go ahead and put that down there and just erase our extra work here. Pick up the eraser that I dropped on the ground. Okay. So when we subtract away, we know we're going to have to borrow, make that a 3, and that becomes 12. So 3 minus 1 is 2. 12 minus 6 is 6. Now we slide this box over, and we have one more place value that we need to bring down, and we'll put that in the 3. So now again, we have to figure out how many times will 29 go into 263. You have to guess and check. Now the largest possible number there could be is 9, because we can't do any more than one digit here. And the largest digit would be 9. We know it's more than 4, so now we've narrowed down our guesses between 4 and 9. So if you work through it, you actually find out, and if you got this right, you already found out, the closest you can get would be 9. And what is 29 times 9? That comes out to be 261. So we're so close. Now, when we subtract out, we have a remainder of 2. So our remainder is written as a fraction. This is how you do it. The 2 becomes your numerator, top number. And the original number we had over here outside the box is 29. That's your denominator. 2 29ths is what's left over. So the question says, if the owner wants to split the fish into the tanks evenly, what's the greatest number of fish that will be in one tank? Well, you may say 49 and 2 29ths, but because there's a little extra, you may say your answer is either 49 or 50, okay, fish. This is the exact answer. This is the realistic answer. So I was looking for the 49 and 2 ninths. If you had 49 or 50, I guess I can see where you came up with that. All right, let's go on to example 2. It says a store manager has 224 pairs of jeans that they need to stock on the shelves. Each shelf can only hold 18 pairs of jeans. How many shelves does the manager need to stock all the pairs of jeans? We're going to need to follow that same algorithm that you have written in your notebook to be able to interpret this quotient differently. So in working through this, we know that we're going to have to try to find how many times 18 will go into 224. Now, if this was my store, I would just try to make them fit 20, or I'd pick a number that's a little easier for the math than 18. But we need to stock as many of these out there as possible. So again, let's make a box. I'm going to pause to make the box. All right, so we go all the way over here, and we see, does 18 go into 2? No. Does 18 go into 22? It certainly does. So this math is a little easier. 18 goes into 22. We know that to be a once. So when we subtract away, we find out that we have a remainder of 4. So again, we slide down over to the next number, and we keep working. This is actually the last one, but we have to bring that 4 down. And now we have to see how many times will 18 go into 44. Well, if 18 goes into 22 once, 44 is double 22. It's probably only going to go in 12 times. Let's try that. 18 and 18 gives you a 36. And we are going to have a number just a little left over here. So we know we have to borrow here to make the 3, and now we have 6 and 14. So how many times does 6 go into 14, or subtract away? You get 8. So our answer, why did I finish? There we go. So we have 12 and 8/18 genes. Now, does that make sense? Can you actually have part of a gene on a shelf? They're not going to be cutting up the genes. So you have to think to yourself with this answer, if you can't fit another pair of genes on there, what's the largest, as it says, what's the largest number needed to stock the shelves? Well, the largest they can do, the largest whole number here we get is 12. So the answer is 12 genes per shelf. We are looking at the problem in a realistic scenario that you can't have 8/18 of a genes sitting on the shelf. Write this down before moving on. All right, it's your turn to try these two problems out. Come back when you're done. We'll see if you got an answer close to mine. Good luck. So here's what I got. So for the first one, I had to see how many times 51 goes into 607. So I covered up. That doesn't work. 60 works, so that's how I got 1. I was left with 9. I had to bring down the, I had to bring down the 7. And now I had to figure out how many times 51 goes into 97, which is only once. So I was left with 11 and 46 as a remainder over 51. Realize that's pretty close to 12, so I just said about 12. Oops. There we go. For the picking of apples, when I did it, I came out with 32 and 27/34. Well, how many whole apples? I can't cut up an apple, so it has to be 32 apples. There'll be 27 apples kind of left over, and figure out what we want to do with that. Maybe make apple pies. So hopefully you did well on these problems. All right, for your box of thought today, I want you to pick one set of questions or the other. You can pick the first one or the second ones, and all you got to do is answer them in your notebook and then write down your answers in your notebook so I can read them when I check off your notebook. A lot of times I said notebook there. Here is your quiz. So you have 3 questions. Show me your work, and I'll be checking your notebook when you're done up at the front table. Hopefully you do well. If you have questions, come ask me. And that's it for our lesson. See you next time.